Hello friends, welcome to yet another lecture on chemical engineering thermodynamics. Today we will study about heat engine and heat pump. What is a heat engine? A heat engine converts heat that is taken at higher temperature to work. It rejects heat at a lower temperature. What is a heat pump? Heat pumps takes heat at lower temperature, adds work to it and discharges the heat at high temperature. A refrigerator is a heat pump. On the screen now, you have a schematic representation of an ideal heat engine. On the left, you have the Carnot cycle represented in the PV diagram. Here, heat QH is taken reversibly by the Carnot's engine at temperature TH. Work WT is done to the surroundings. Then the Carnot's engine rejects heat QC reversibly at temperature Tc. Then a work Wc is done on the Carnot engine's fluid to bring it back to the beginning state. On the left, you have the schematic representation of the Carnot's engine. Heat QH is taken by the heat engine and heat QC is rejected and work Wnet is done. Now we have a schematic representation of a heat pump. On the left, we have a representation of the heat pump. A heat pump, an ideal heat pump, is nothing but a reversed Carnot engine. Here, heat QC is taken at Tc by the reversible heat pump. It expands, the fluid in the Carnot engine expands. Then the work WT is done on it to bring it at temperature TH. Now heat is rejected by the fluid. The heat rejected is QH and then afterwards a WC work is done to bring back the fluid to the original state. The schematic representation of the heat pump is shown on the left where heat QC is taken and heat QH is rejected and Wnet is the work done on the heat pump. The heat engine is rated by its efficiency. The efficiency of an ideal engine or any engine is defined as the work it does over the heat which is supplied. Now, if we apply first law to the Carnot's heat engine, we get efficiency as heat taken minus heat rejected divided by heat taken. Or the efficiency can be written as 1 minus QC by QH. Now from Carnot's principle, we have Tc by Th is equal to Qc over QH. Therefore, the efficiency of a Carnot's engine is 1 minus Tc over Th. The heat pumps are rated by their coefficient of performance, that is COP. The COP or the coefficient of performance is defined as the heat taken by the heat pump divided by the work that is input to the heat pump. By applying first law, we get the COP as QC over QH minus QC, where QH is the heat rejected by the heat pump and QC is the heat taken by the heat pump. From Carnot's principle, we have Tc over Th is equal to Qc over QH. Therefore, the COP is nothing but TC, TH minus TC. Now this is for an ideal heat pump. Hope you have understood the concepts of a ideal heat pump and a ideal heat engine. If you have any doubts, do write back in the comments. Have a great day. Bye.